So, from what I saw in class, people were having some difficulty graphing systems of linear inequalities. So my objective for this video is to graph quite a few of them relatively quickly. I'm not going to explain too much. I'm just going to talk straight through it as I work it out. So, starting off with this first one right here, I've already solved for y on both of them, so they're ready to be graphed. Let's start with this one on the right. I'm going to start at positive 4. My slope is 1 over 1, so I go down 1 because that's my rise, negative 1, and then right 1. So down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1, and that continues as far as I really want, but I don't need but 2 points to make a straight line, honestly. So let's go ahead and make that line real quick. Something like, that's close enough for now, for this video. So it's a dotted line. It's dashed because I don't have an equal sign below that inequality is strictly greater than, so I'm just going to make a dashed line, and that will do for now. It's dashed. Also, it says that y is bigger. So, from right here, where are my bigger y's? Above. I'm just looking solely, just to explain something real quick, I'm looking only at this. A lot of my students, for some reason, will say, do I shade on the left or right? I look up and down. I don't necessarily say left or right of the line. So when I'm looking up and down, from this point, it says that y is bigger. So where are my bigger y's? Y is bigger. Where are my bigger y's? Up or down? Up. Now the question becomes, all right, here's my bigger y's. What side of the dotted line am I on? This side. So I shade this side. Alright, so that's my first inequality shaded. Next, this one starts at positive 2. My slope is 3 over 1, so start at positive 2. I go up 3 over 1, up 3 over 1, up 3 over 1. So again, I don't really need to make even more lines, so that's good enough, or dots, I mean. That's good enough. It is equal to or less than, so I'm going to make it a solid line. By the way, if you're confused about that, if your inequality sign is strictly greater than or maybe strictly less than, then it's going to be a dotted or dashed line. If it has an equal to sign below it, so if it's equal to or less than or equal to or greater than, it's going to be a solid line. So here's the line I just graphed. This says that y is smaller. So again, I'm only looking at my y-axis. Here's where it intersects the y-axis. Where are my smaller lines, or smaller y's for this one? That's y. So it says y is smaller. So where are my smaller y's? Right here. Downward. What side of the line am I on? I'm on the right side of that line. So I'm shading right here. Okay, and you can see where all my cross-hatching is happening. That's where this area right here, that's my region of feasibility. That's what it's actually called. Where all of my shading is intersecting, where all of my solutions lie. This is called the region of feasibility. All in here. And I'm not going to spend too much time making it perfect, so there it is. Region of feasibility. I'll write that out. Region of feasibility. I sure hope I'm spelling this right. Fees and then ability, feasibility. Alright, on to the next one. This one, y is already solved for on this equation. I got to solve for y on this one. So I'm going to move the 4x to the other side. That's going to make it negative 2y greater than or equal to negative 4x plus 8. I'm going to divide by 2 on both sides now. So I've got y greater than or equal to negative 2x plus 4. Just so you know, anytime you ever divide by a negative or multiply by a negative, so only dealing with negatives, if you divide or multiply by a negative number, this inequality sign will change directions. It will negate. It flips directions. And I'll specifically go through an example like that in just a second. So here's this equation solved for y. Graphing it, I start at positive 4. My slope is down 2, right 1, down 2, right 1. So down 2, right 1, down 2, right 1. Got enough lines there. And it's greater than or equal to, so it's a solid line. There it is. arrows on each side showing that this line continues on forever. And then I want to shade above where my y's are bigger. Again, I'm just looking at my y-axis. So here's my bigger y's. What side of the line am I on? I'm on the right side. So I'm going to keep shading on the right side where my y's are bigger. Okay. So next, right here, start at -3, 2, 3. And then I'm going to go down to right 1, down to right 1, down to right 1. Well, as you can see, I got a -2x and a -2x. These things should be parallel, which they are. So again, I'm going to go ahead and shade that. Something like this. It's not exact, definitely not. Okay. Well, close enough. Close enough for now. Alright, and this says that I should be shading y is below. So right here, again, just looking at this line and looking at my y-axis, there's where my y's are smaller. Notice this one says y's are smaller. So I'm shading below where my y's are smaller. I'm on this side of the line. And if I finish shading this whole region right here, I would see that my shadings never intersect, so there is no region of feasibility. There are no solutions. No solution. Okay, I'm going to skip this page now, and I'm going to go on to some other ones. Let's go ahead and let's do some of these, actually. Okay, I want to do this one specifically. So it says, write the inequalities that form the shaded region. Okay, well here is a shaded region. The inequalities, let's start with A, I guess. So here's one line. First thing I notice, it's a solid line, which means that it's going to be with an equals to on the bottom of the inequality. It's going to have that equals to on it. It's solid and it's shaded above. So it's saying that the y's are bigger. So y is greater than, not just greater than, it's a solid line, so it's greater than or equal to. Now what's the equation, or what is the expression representing this line? So looks like it intersects the y-axis at -2.5, so I'm going to put that -2.5 for a y-intercept. And what's my slope? Well, it looks like for every time it goes up 1, it goes over 1, 2, 3, 4. So every time it goes up 1, it goes over 4. So up 1 over 4x. So there's my equation for A, or my inequality for A. Let's do B now. B, again, is a solid line, and it looks like it's shaded below on this line where the y's are smaller. So this is going to be less than, and it's a solid line, so it's equal to, less than or equal to. Where's my y-intercept? I don't know. Right now, let's see what my slope is. 1, 2, 3, 4, 5. So I'm starting at a solid point, by the way. And that's the easiest way to find a slope. Start at a solid point and count to where the next solid point is. So 1, 2, 3, 4, 5. It goes up 5, left 1. So for every 5 units that it goes up, it goes left 1. So I could write that as, I'm going to write it to the side. I could write up 5, left 1. Or I can realize that 5 divided by -1 is -5. So I'm just going to write it like that. -5x. And the question now is, what is my y-intercept? We can't see where it actually hits the y-axis. We can guess. We can make a complete guess. But I don't want to do that. I want to know. So if it's going up 5 for every one time it goes over, how much further do I have to go over from here to hit the y-axis? I've got to go over 1. And if I go over 1, again, we know that for every 1 we go over, we got to go up 5. So from here, I'm at 3, 4, 5, 6, 7, 8. I went up 5 more, which means my point is going to be at 1 over, and it's going to be on the y-axis. So it went up 8. Up to 8. So that's my y-intercept. And I knew that because of the slope. Again, so 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. So I'm 8 high right here. And then finally, C is right here. And it looks like it intersects the y-axis at +1. So I'll start on this side of the equation this time. +1, my slope is from a solid point right here, up 1, 2, over 1. Up 2 over 1, up 2 over 1. So 2x, I could put 2 over 1 if I wanted my slope like that, but it doesn't really matter. I'm just going to leave it as a solid 2x. That's the same thing as 2 over 1. Now, my line is solid, so again, it's going to have the equal to part on the bottom. And then also, looks like I'm shading below, so it's going to be equal to or less than y. So those are my three equations, or inequalities that represent my graphed inequalities right here, that shaded region. Okay. Let's go ahead. Let's see if there's any very difficult ones on here. Let's do number 7. That looks kind of difficult. Number 7. So, starting off, I need to solve all of these for y. So I'm going to go ahead and move this over here and solve it. So when I do that, it's going to be y is less than negative x, because that moved to the other side, plus 5. Solve this next equation, or inequality. It looks like it's going to be y. I move the x over to the other side again, so it's going to be negative x minus 5. This one, I'm going to move the x over. That one actually is going to take a little bit more work. So I'll work this one out, still to the right. So I've got negative y is less than, and I've moved the x over, so it's going to be negative x plus 4. But the problem is I've still got a negative y. So I've got to get rid of that before I can graph this. So I'm going to divide by negative 1 or multiply by negative 1. It's going to do the same thing. Now the problem is, with inequalities, when you divide or multiply by any kind of negative, that sign changes directions. So let's say we multiply by negative 1, so I've got y is greater than. So notice how the sign changes directions. Negative x times negative 1 is going to be positive x. Positive 4 times negative 1 is going to be negative 4. So there's that equation. Now I'm going to go ahead, or inequality, I'm going to go ahead and solve this one too. So again, I'm moving the x to the other side. It's going to become negative. So I'm going to have negative y is greater than negative x minus 2. Negative x minus 2. Next, I have got to divide or multiply by negative 1 to get rid of that negative. Again, the sign is going to change. So y is less than x plus 2. So there's my last equation, or inequality. So I'm going to go ahead and graph all of these now. Graph this one. I'm going to start at positive 5. I'm going to start at positive 5. And I'm going to go down 1, right 1, down 1, right 1. A lot of people have trouble with that for some reason. The deal is, guys, the question, how many negative x's are there? There's negative 1x there. And then you can always put any number over 1 and it doesn't change anything. So that's my slope, negative 1 over 1. When you have an x by itself, it's 1 over 1. So here's my line. It's a dashed line. So I'm going to be shading, looks like below, because y is smaller. So again, right here, shading on this side where the smaller y's are, so somewhere in this area. Alright, next. So we're done with this one. Let's go on to the next one. Y is less than negative x minus 5. So I'm starting at negative 5. I've got another negative x, so it should be the same slope. Which means that these lines are going to be parallel. Again, it's going to be a dashed line because it's strictly less than. Oh, look at that, man. I made a mistake. So this says that y should be greater than. So that actually should be a greater than sign. Glad I made that mistake and saw you guys, or gave you guys an opportunity to see me make a mistake like that. So, greater than. And the reason I knew that was a mistake is I knew if I was going to graph this and it was going to be less than, then I'd just be graphing or shading where I already shaded, which is not going to make much of a difference. So I knew something was wrong right when I saw that. So this says y is greater than all that. So I need to be shading above. So now I can see that my region of feasibility is going to lie between these two dotted lines. So let me go ahead and do that. So shading where the bigger y's are. Up this way. Okay. And I can continue to shade above that if I wanted, but I already know that I can't have any of my solutions up here because this one wasn't shaded there. So I'm just going to go ahead and shade inside this area. And again, in case that was confusing what I was just saying, all I was saying is that I'm not going to go beyond this line because this inequality says that the solutions don't lie above that line. So I'm just going to shade up to that line and stop. Next, here's my other line. So it starts at -4, which is right there. And it goes up 1 over 1, up 1 over 1. Again, that's 1 over 1. So -4, up 1 over 1. Okay, something like that. So I'm just going to use this ID. And this is, wow, these are all dotted lines. They're all dashed. So dashed again because it's strictly greater than. Oops. Strictly greater than. So it's dashed again. I need to make sure I'm shading above where the bigger y's are. So now that's going to be on this side, somewhere in here. But again, I know it has to be limited to right here somewhere. Now I'm somewhere in this area. It's getting kind of tougher to see. Lots of shading going on. So I'm somewhere in this area. And then last line, this one's going to start at +2. Right there, and it's going to go up 1, right 1, up 1, right 1. So again, connecting all these with a dashed line. Except this one is shaded below where the y's are smaller. So here's the y-axis, I'm shading in here on this side of the line. And now, finally I get my area of feasibility, which is really hard to see. It's right here in the middle. That very dark area. Wish there was something that I could... Oh, I got the perfect idea. Here we go. Area of feasibility where every single inequality overlaps is right here. Okay. So, let's see. Is there anything else that I want to go over? I like number 6. For some reason, people still have difficulties graphing these types of lines, and I think it's because they're trying to memorize things. The point is, here's my x-axis, here's my y-axis. This says that x is smaller than 6. Where does x even equal 6 at? X equals 6 right here. And then, for the people that memorize things, this is the question I like to ask them. Where else does x equal 6? So yes, x equals 6 there. There's other places that x equals 6. Right here. Right here. Anywhere on this thing, x equals 6. So for example, right here, x equals 6. Y might equal -10, but x still equals 6. So you've got a vertical line that is going to be, again, dashed, unfortunately. So dashed vertical line, and it says that x has to be smaller, so it's shaded somewhere over here. Next, y is bigger than -1. So here's -1. That's where y equals -1. Where else does y equal -1? Anywhere on this line. While x might equal 10 here, y equals -1. Still, y equals -1. Anywhere on this line. And so, here's my next line. And it says that y is greater than, so where are the bigger y's at? Bigger y's, again, I'm just looking at my y-axis. There's the bigger y's. So I need to be shading on that side of this line. So now I'm somewhere in this area. Alright, so lastly, it says that y has to be less than x. So the line y equals x, again, this is just a 1 over 1, and it doesn't have a y-intercept, so it has a y-intercept of 0. So I start here at 0, and I go up 1 over 1, up 1 over 1, which will make a diagonal line. Something like that. That's pretty close. Okay, so there's my last line, diagonal, and I need to be shading, looks like below, so it says y is smaller than that. So that just refined everything to this little bitty space right in here. I'm shading below this line, to the left of this line, above this line. There's my feasible region. There's where all of my solutions reside. Okie dokie. Let's see. Write a system of... Nah, let's not do that. That's going to take too long. Here's something that I want to discuss real quick. This last one. Prove that negative 2 is a solution of the system of inequalities. There's two ways you can do this. You can graph that, and you can prove that that point resides in the feasible region, where all the shadings intersect. Or you can just take this point and plug it into each inequality, and if both of those inequalities check out and are true statements with using that point, then that is a solution. If one of them is not, then it's not a solution. Let's see. Anything else? I think that should be enough for you to effectively complete this homework and understand the concepts here. All right, guys. Well, I appreciate you watching, and we will talk more about